This is the fourth proof of the Pythagorean theorem. This one is interesting because it doesn't bring any new pieces in. It starts with the a squared and the b squared, and their areas are added together, so we get a squared plus b squared. And what we do is we rearrange these two areas to form the c squared. And we show that by first doing this. We think about cutting a triangle. Now remember, a and b, the a squared and the b squared are right next to each other. So we cut a triangle out of it, where we match up one of our triangles, the side with a, and then the b extends out. And we also cut another triangle there. So this distance is a plus b, so we cut, even though the squares come together here, this is A and that's B, we cut them to this is B and that's A. And we do that by matching our triangles up B to B and A to A. Then we think about putting hinges right here on that corner, right there on that corner. And we're imagining that we've literally cut through there. And in the process, we rotate with this piece on its hinge. It's hard to do this with pieces that slide, but you rotate this piece on its hinge until it comes around and it sits right there. And I show this with my pieces. I've made an extra triangle to show the class. I put that there and say, okay, that piece is just gone. We've removed that area and we've rotated around and put it there. And then we take this piece on its hinge there and we rotate it around all the way through until it sits in there. So we cut out that piece too. And what we see is we've created a square with side C. We know that's C because of the triangle that we cut out. That was the hypotenuse, same thing there. So we've created, just by cutting and rearranging the pieces, we have created a c squared. So we say we start with a squared plus b squared. We cut and rotate two triangles. And we form the c square. And from there we conclude that a squared plus b squared is equal to c squared. Since we rearranged the parts, we went from the one part of two shapes being put together, and we showed how they could be rearranged into just the one shape, the c squared. So if you're going to use this proof as the one that you memorize, since I'm for the camera, I had to put a black paper back there and I couldn't really draw. The idea that you would draw would be this. You can trace around your a squared and your b squared pieces. And you're going to use your triangles and you're going to trace that triangle there and that triangle there. So this is A and this is B, and this distance is B and this distance is A. And then you draw in your hinges and you draw an arrow showing that this piece rotates around, and you draw it up like this, and this piece rotates around and it fits in there, and there's C and there's C. And if you want to, you can put some little shading in there to show that it moved. If this is the proof that you want to do, you would do a drawing something like this, and you would write these things down, and you've got it. Almost forgot. We have proved what we set out to prove.